This conference will now be recorded.
నాకు 2 విషయాలు తెలిసినాయి ఈరోజు ఈ కథలో.
Can you hear me now?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay, thank you for that. Uh, so I was just talking about the agenda for the session. So I was just going through all these points where we'll start off with understanding the courses that is starting today, and we'll understand the institute overview. We'll also understand the electronic system, where we'll understand the fine difference between VLSI and embedded system. Then we'll talk about VLSI design flow. What is front-end domain? What is back-end domain? And then we'll talk about VLSI domain, different job roles, and what is the skill set required. Then we'll talk about the how to choose the right domain. Then institute facilities, and we'll discuss about how to prepare for the job. Then why career in VLSI, and the placements, earlier placement record in our institute, and how we are going to support you with the placements. Then we'll address any questions you may have. Okay. Just about myself, I'm the founder of the institute. I have dual degree from IT Madras, 11 plus years of training experience, and I have 14 years of industry work experience. Uh, let's now start with the session where we'll talk about what all courses we are starting today. As you see, Sumana, please be in mute. You see, in VLSI, there are a lot of domains are there. I mean, I was talking about VLSI being front-end domain and back-end domain. So this itself has another 5 domains. This has another 6 to 7 domains are there. And when I say in front-end domain, there are things like architecture. Okay. Then we do RTL coding, RTL design. Then we do RTL integration. Then we do RTL verification. Similarly, in backend domain also, there are multiple domains are there, which starts from synthesis. Sorry. So it has synthesis, physical design. Then we have static timing analysis, the IR drop analysis, some layout. Then it has got physical verification. Like that, there are multiple subdomains are there. Even though I'm writing 5 and 7 here, it could be more. Let's say if I take DFT, we do at the RTL level. So here also we do DFT. Here also we can do DFT. Like that, each domain, front-end domain and back-end domain, has multiple subdomains. One person doesn't work on all the things. Let's say, for example, in my case, I have only worked on RTL verification throughout my career. For starting from the 2005 till 2019 when I was in job, I have only worked on RTL verification, nothing else other than that. So someone who got into physical design will only work into physical design. Now, okay. Now coming back to our slide, courses starting today. One of the things as an institute we have been doing is we offer training in most of the things here, except for architecture part. We offer training in RTL design. We offer training in RTL integration, verification, DFT, synthesis, DFT, every domain. We cannot have a dedicated demo session for, yeah. we don't have a dedicated demo for each and every topic. Rather, what we do is we offer two demo sessions. One is the front end demo, one is the back end demo. The front end demo is what is happening now, and back end demo will be tomorrow, same time. Okay. Further, those who are interested in specific courses, let's say someone is interested in DFT, so they will have a see, they can attend today's session to just to get an overview of the VLSI flow and the courses that are being offered. We will have a DFT specific demo again at 4 p.m. today. Okay. Similarly, someone who want to attend FPGA training, they will have a dedicated demo for that. So that my trainer who does DFT demo doesn't have to go through all the things. He can only focus on DFT specific things. Okay. Now coming to backend demo, tomorrow it will happen. And if someone wants to attend, let's say custom layout, they'll have a dedicated demo session. Someone want to attend synthesis and STA, they'll have a dedicated demo. Okay. So basically two common demo sessions are there. Then the domain specific demo sessions also will have. First of all, today we are starting off with one of the courses, RTL design and functional verification. So you see here we are talking about two things, RTL design and RTL verification. So when I say the term RTL verification, I'm actually referring to a term called as functional verification. Can you tell me why are we calling it as functional verification? We are correctly or not? Yes, exactly. So we are checking the functionality of the design. Basically, when we develop the chip, there are multiple things we can verify. We can do the timing verification. We can do the power verification, power aware verification. We can do the physical verification. We can do functional verification. That means throughout the flow, starting from the time we get the requirements of the chip till we manufacture the chip, it goes through different stages of verification. Because once the phone or anything is manufactured, any electronic product is manufactured, if it doesn't work for any reason, it could be functionality, it could be because of the power issues, right? It could be because of some physical issues. It won't work, right? I mean, then you won't use the phone. It's not just about functionality. So that means during the entire chip design flow, different types of verification is done. One is called as functional verification. One is called as timing verification, which is similar calling as STA, static timing analysis. So there we are doing actually timing verification. Then power aware verification. This is related to power behavior. I mean, I won't go deep into it, just one of the concepts. Okay. Then we have one more thing called as physical verification. So term verification is very generic. If you go deep, there are different types of verification we can do. If you ask me what is the work I did when I was in the job, I only did functional verification. There will be so many things to do in functional verification only. While just being in functional verification, you can grow and reach bigger positions. So you don't need to really look at anything else other than functional verification. Okay. So in summary, we have to be very specific when we say I'm into verification. It could mean any type of verification. So the one we are starting today is RTL design and functional verification. So that is same as that course is same as front-end training for freshers. Let's say some of you have enrolled for a course called as front-end training. So we are referring to the same course there, where you are going to learn RTL design, you are going to learn RTL functional verification. That is again same as design and verification course, which is same as functional verification training for freshers and ASIC verification. Why I'm telling is whichever term we use, it's all the same course we are referring to. Other than that, we have a course meant for functional verification training for experienced engineer. So what is the difference between functional verification training for freshers and experienced engineers is those who are already working in the industry would be very comfortable with digital electronics and the Verilog. Okay, they may have some things lacking with respect to advanced things like system Verilog and UVM, some industry level projects. Generally what happens, those who are working in the industry, okay, they don't get to work on everything in the flow. Let's say the the functional verification starts from reading the specification. You take a document called as specification till we do the coverage closure. Okay, what is coverage we'll discuss as we go forward. For now, it starts with the reading of specification, it goes till where coverage closure, what we call as functional coverage, code coverage closure. Okay, the person who works in the industry doesn't get to work on that entire flow. They will only work on test case development. They'll only work on doing the coverage analysis. Okay, like small activity they'll get to work on. Our course is meant for giving them exposure to the entire flow. I mean, how to start reading the specification and how to do the closure. So it is meant for those people, but since they are already working, they would be comfortable with digital electronics and Verilog. So for them, these topics won't be there. So their course will start with system Verilog, UVM, standard protocols, and multiple industry standard projects. So in summary, functional verification for experienced, same as functional verification for freshers, minus digital electronics, minus Verilog. There won't be any Verilog, plus UVM advanced course, which is not required for freshers. For a fresher, UVM basics course is sufficient. One what we call as UVM essentials. That would be sufficient for you. You don't need to do advanced level of UVM. But for an experienced person, advanced level of UVM is required. Okay. So this is the experience course basically. We are also starting today the Verilog for design and verification and system Verilog for functional verification. This is meant for students who are pursuing their BTech and MTech, who are in the third year or fourth year of their BTech and MTech. They'll be already busy with their either project or their coursework, so they won't have time to do the entire course. So they can do these courses in 1 to 2 months time. Okay, and that will help them clear the internship interviews or campus placements. It will help. Other than that, we are also starting today a course on FPGA design and verification. In later part of the today's session, we'll understand that VLSI is basically two types. Whatever you do in VLSI can be two types. One is ASIC, one is FPGA. Okay, so we also provide training in FPGA domain. Then we are also providing training on RTL design and integration. You see here it is RTL design and verification. Here it is design and integration. Someone who want to get into the design domain. So this is for someone who want to get into verification domain. Okay. Other than that, we are also starting a course on DFT, which is design for testability. So the front-end demo session is from 9:30 to 12:30, okay, around 3 hours. And DFT demo session will be by 4 p.m. today. Okay. Our admin will send you the details regarding that session. Okay. So this is a brief about the courses that are starting today. Any questions before we move to the next topic? What is difference between verification and integration?
Hello.
Yeah.
So, is there any separate batch for functional verification for experienced guy or? you will add in between the courses of functional verification for freshers when
Yeah,
they
you
will
will be
just complete the till very long.
actually what happens, we start a new batch once every 5 to 6 weeks. If you want to start from this week, there is a batch which would have started 1 or 2 months back. You can start into that. For example, this Monday, the system Verilog course is starting. That is the starting course of functional verification for experienced engineer. So you can start with that. You don't have to wait for another 2 3 months for system Verilog to start. You can join into one of the previous batches that has started.
Okay, but that batch is for freshers, right? Means just the thing is from system Verilog, it's going to be
Ye-
start, right?
yes, exactly. Yeah.
Then will it cover UVM advanced?
It will cover UVM advanced. For you, UVM advanced is done as a separate track. It
Okay,
will,
understood.
yeah.
Understood. Yeah, yeah. Okay, thank you.
Let us understand what is the difference between verification and integration. So in this case, just take one of the presentations. Okay. If you take this diagram, for example, this is an example of a SoC, which is system on chip. Um, this is what finally goes into the chip, then which goes into my electronic product. Okay. That has got various subsystems. What is this one? CPU subsystem. This is GPU subsystem. This is DSP subsystem. Putting together different subsystems makes the SoC. That concept is called as integration, where someone has developed, the person who develops this code is called as design engineer. Means let's say I'm developing this IP, I'm developing AES. Okay. That person is called as RTL design engineer. The person who gets all these things and puts together everything is RTL integration engineer. The person who verifies that this whole thing is working as per the design specification is the functional verification engineer. So that's the difference. Any other questions you have?
So same RTL design engineer will become RTL integration engineer, right? After some experience.
No, it's up to the person whether he want to move into RTL integration or not. Typically in a team, there will be a different set of people for different activities.
Yeah, but during starting of career, one can't be a RTL integration engineer, right?
Why can't it be? It can be. It is possible because let's say you start with RTL integration, they won't give you the entire integration activity. Okay. So
Okay.
typically, what happens? Uh, People can get into minor roles. I mean, typically you join into a company, they will give you simpler activities called as linting and CDC. I mean, RTL integration has some 8 activities below it. If I take the term RTL integration, that itself consists of 8 sub-activities: linting, CDC, UPF, okay, LEC, synthesis, STA, lot of topics are there. So the person who starts his career, they won't give the entire work. They'll give a smaller activities. As he learns, then they will give the full activities. So it is not compulsory that the person has to start as a design engineer. In fact, for that matter, in India, there is no design activity happens.
Oh, yes, majorly not. Yeah.
Any
But
other?
like in colleges, like they don't teach CDC, Lean, these things, right? So very difficult to get first job as RTL integration engineer, right?
See,
We need to do courses for this CDC, Lean, and these things. Hello.
yeah. So my point
Hello.
is, yeah, colleges don't teach whatever is exactly required for that. companies. So that is where the finishing schools or the training institutes are there to fill that gap. Any other
Yes, Mr.
questions?
So is there a course for this also? Like, do you provide for
Which
this
which
also?
one? Which
RTL
one?
integration?
I mentioned, right? RTL integration also you can do if you want.
Understood. Yeah, thank you.
So let us start off with understanding electronic system. Here the basic idea is, please. So basic idea is to help you understand what goes into an electronic system, what all layers are there, those things. So before we start with this, let's assume that this is a mobile phone. Okay, what all things do you see in a mobile phone? What do you think mobile phone consists of? First thing you see is the hardware, right? Right. Other than that, is there anything that makes up the mobile phone? This, the physical piece you see is the hardware. What else do you see? You see, can mobile phone work without having an operating system? Say you have a mobile phone, it could be Apple, it could be iPhone, or even Android based, anything. Will it work without having an operating system? Okay, so operating system is required. Other than that, there will be something called as firmware, drivers or things. Okay, firmware. Without that is also essential. Fine, you have got the mobile, you have got the firmware, you have got the operating system. What else do you need in the mobile phone for to use it effectively? You've got the hardware, mobile phone hardware, you've got the firmware, you've got the operating system. What else do we need? You need applications, right? You need application apps that we install, right? Without apps, you can't do much with the operating system alone, right? It could be using WhatsApp, it could be using Google Maps or anything, right? So you need the apps. Okay, so that is what an electronic system basically consists of. Majorly 4 layers will be there. At the basic level, you have got the hardware. The hardware is controlled by the firmware. Okay, firmware gives instructions to the hardware how to behave. Okay, then on top of hardware, on top of firmware, you have got operating system. Okay, so operating system gives instructions to the firmware. On top of operating system, we have the applications. Even if you take a little complex example like laptop, it also works in the same manner. Okay, my laptop has a hardware, then there are drivers. I can call them as USB drivers, SD card drivers, HDMI drivers. So those hardware will work only when those drivers are present. Let's say USB won't work if there are no USB drivers. My laptop should have USB drivers, only then it detects the pen drive, whatever you connect. That is the second level, what I'm calling as firmware. So when I use the term firmware, when I use the term hardware, sorry, drivers, both are same. Then on top of firmware, what you have got? The operating system, that is the Windows, okay, iOS, anything. Then what else do you have on top of that? Different applications, different softwares we are using. Let's say PowerPoint is an example of a application that I have installed on top of operating system. So any electronic system, a little complex one, can be understood in these 4 layers. Okay. As a VLS engineer, which layer do you think we are working at? What is the layer we are concerned about as a VLS engineer? Are we concerned about hardware? Are we concerned about the firmware, software, or applications? Hardware.
Hardware.
So a VLSI engineer is responsible for development of the hardware. It is not like one person can just do everything. So that itself is the whole process of developing the hardware itself is divided into multiple stages. So that was the first thing I started with, where I said the whole VLSI flow can be divided into around 15 steps, which can be classified into front-end domain, back-end domain. Okay. So we'll talk about all that. But before we go to that, let's understand what is an electronic system. Okay. You take a mobile phone, what all things do you see? First thing you see is only the hardware part of it. right, which consists of some GPU subsystem, CPU subsystem, multimedia subsystem, some camera, touch screen, different things. Okay. First thing is the hardware, which could be things like chips, processor, screen, USB port, camera, sensors, audio, different things that makes the hardware. You see, there are things which we don't see, like what? Operating system, the firmware, the applications. This is all required for my electronic system to work effectively. So in summary, the mobile phone or any other complex electronic system has four layers that make it up. One is the hardware. Who develops hardware? What is that person? That is the hardware engineer, or more specifically, we'll call them as VLSI engineer, our case. Okay. Next. The person who develops firmware is nothing but the different drivers. Who is the person who develops firmware? It is embedded system engineer. So that is the difference between VLSI engineer and embedded system engineer. So the VLSI engineer is responsible for development of hardware. Embedded system engineer is responsible for development of the firmware. Then we have got third thing, operating system, like Android OS, Android, iOS, Windows, Linux. Okay. Who develops OS? It is the software engineer. Then we have got applications, right? Apps in the mobile, GPay, maps. Who develops apps? It's the software engineer, okay, or app developers. So all these four layers are essential for electronic devices to work. You can't think of a mobile phone without operating system. We can't think of mobile phone without applications, right? Let's take it to understand this concept of four layers. Okay, let's take a simple analogy so that you understand how that interaction happens. Let's consider a bus with passengers. In that case, bus is like the hardware. Actually, the bus is the hardware. You have a driver who controls the hardware, right? Who controls the bus? Is it the passenger? Is it the conductor? Is it the driver? Driver. So that is the reason. That is the very reason. Even in firmware, they use the term drivers. Like they call USB drivers. They call HDMI drivers. Why? These drivers, okay, control the hardware behavior. Then we have got the conductor. He is like the operating system. So he carries the information between the passengers and the driver. Let's say I want bus to be stopped. So I will inform to the conductor. So conductor informs driver. Okay. Passengers are like applications. So use case is what? A passenger wants to stop bus, right? He will not go and press the brake, right? Passenger. He will inform to the conductor. He further informs the driver, and driver will control the bus to stop. Okay. So driver also has some controls are there. What are those controls? The accelerator, brake, clutch, handbrake, different things are there. Similarly, even when firmware wants to control it hardware, the hardware will have something called as registers. Hardware will have something called registers, configuration registers and status registers. Okay. By programming the configuration registers, the firmware controls how hardware should behave. Let me again repeat. My hardware will consist of registers. One register is nothing but 32 flip-flops. A 32-bit register means 32 flip-flop. That flip-flop can be D flip-flop, can be JK flip-flop, SR flip-flop, anything. Okay. By programming, by setting some values into those registers, the firmware will decide how hardware is going to behave. A simple example is like the washing machine. For example, we have switched on a washing machine now. It is running for 30 minutes. There is another mode where it will run for 1 hour 30 minutes. Different modes are there. There also what is happening is when you are turning the knob for different modes, inside my washing machine hardware, there are registers which are getting programmed with that value 90 minutes, 30 minutes, 120 minutes. They're getting programmed accordingly. That is how the hardware knows how I have to behave. Okay. So let's repeat again. So how does the firmware control the hardware? By programming the registers that are present in the hardware. Inside the hardware, there will be something called as configuration registers. Why the term configuration? Because we are configuring the hardware behavior. So one of the driver example, let's say you connect USB driver is connected to the laptop. Sorry, USB device is connected to the laptop. Okay. So what happens? First of all, USB device gets detected. My laptop will detect that pen drive has got connected. So we start doing the transfers to USB device. So what happens is, whatever transfer you do, you need to give, let's say this is my laptop, this is my pen drive. Okay. So whatever communication happens between them happens in something called as frames. They're called as USB frames. It is the responsibility of this USB driver to generate those frames. Who can you tell me whose responsibility is to generate the frames? It is the responsibility of the USB driver to generate the frames. Driver typically consists of assembly instructions, machine code, okay, which processor will understand. I'm going little deviating from the actual topic, but I'm just to give you a little clarity. What is a driver is if I am an embedded system engineer, I will use embedded C program to control the USB hardware behavior. My coding will be mostly related to writing to the registers and reading from the registers. Okay, that C code, when it is given to a compiler, it generates assembly instructions. The C program, when you give as an input to a compiler, it generates output is a assembly instructions called as machine code. That machine code my processor will execute. That is what is actually happening in a mobile also. Anything I'm running, let's say I open one application or anything, the corresponding driver gets uploaded, comes to the memory, DDR memory, then processor executes those instructions one by one. So I'm trying to explain you the importance of the drivers. The drivers importance they play in the electronic system. So embedded system engineer develops these USB drivers done using which language? Embedded C. Okay. So the embedded system engineer is only responsible for development of drivers. He is not responsible for hardware. Who is responsible for development of hardware? It is the VLSI engineer. So driver, what is the use case? Let's say current mobile, in my mobile phone, screen turn off time is right now 30 seconds. You know, right? What is screen turn off time? If I don't do any activity, after 30 seconds, it goes blank, right? Let's say I want to change it to 60 seconds. Can you tell me what do you do in your mobile typically? You go to the settings, you go to display settings, then you will change the number 30 to 60. So in that process, almost every layer is getting involved. Even though it looks simple, you're changing 30 to 60. You know where the final change, that 60 is getting changed. Can you tell me where is that final change happening? Is it happening at operating system, or is it happening at driver level, or is it happening in the hardware? It is actually finally happening in the hardware. You started at application, you opened a settings there, it's like application. Okay. Your application, you shouldn't directly, so as an application, you don't go and control the hardware directly. How do we do? You open the settings 30 to 60, In this process, in this case, this instruction goes to the operating system. Okay. Operating system conveys this to power management related driver. There will be a driver called as power management, because switching on, switching off is the responsibility of the power management block. See, mobile phone will have something called as power management. This driver consists of instructions for processor writing to a register in the design to change the number 30 to 60. So what that driver will do is, it will change the number from 30 to 60 by writing into a register. My hardware will have a register, it will write into that register to change the number 30 to 60. Next. Why is it important for VLSI engineer to know all these things? I mean, we should only be worried about hardware, right? Why should we know a little bit about embedded system? All that. Going back to the bus example, the person who is developing the bus should know how driver is going to use it. Okay. Right now, accelerator, brake, clutch, even the, what do you say, uh, the hand brake, everything is at one place only. Is it possible where you have accelerator at one place, brake at some other place? No, right? He has to develop the bus in such a way that it is easy for the driver to use it. Same way, as a VLSI engineer, whatever hardware we develop, it should be easy for the embedded system engineer to use it. I mean, he should be able to control the hardware behavior easily. So that is why I should know how embedded system engineer is going to use it. You compare it with bus example, you will easily understand. So as a person who is manufacturing the bus, he should know how driver will use it. Then he can develop a very good bus. Same thing here. Okay. As a VLS engineer, you need to understand how the hardware works. You need to have an in-depth understanding of hardware process. Other than that, you need to know how firmware interfaces with the hardware. It requires a decent understanding of how firmware works with hardware. So we don't need to worry about operating system and application. So this is a brief about different layers that make up the electronic system. What is hardware, what is embedded system firmware, what is software, and what is applications. Now let us more specifically now talk about VLSI. So first we'll start with understanding of VLSI design systems, design styles. So what does VLSI stand for? Very large scale integration. So what are we integrating? So when we say very large scale integration, means you are integrating things, right? What are we integrating? Transistors. Transistors. Okay. So it's like if I construct a house, this building only, what did we integrate mainly? Bricks. Mainly bricks, and other than, of course, windows and many other things are there. But one level, to get the structure, we are integrating the bricks. Similar to that, how many bricks would have probably gone into it? Some thousands of bricks would have gone into it. So here, into a mobile phone chip or some complex chip, how many transistors do you think will go? Some billions, 100 crore transistors. That is why we use the term very large scale. Okay. Can we do that manually, putting together one transistor, connecting one transistor to another transistor, second transistor to third transistor? When you have 100 crore transistor, can you do that manually? No, right? That is why you need one flow, a specific automated process which will help you do that. We are integrating transistors. Since we are integrating billions of transistors, it is called as very large scale. Let's now understand VLSI styles. Okay, means in how many ways VLSI chips can be developed. There are majorly two styles are there. One is called as ASIC, which stands for application specific integrated circuit. The second one is the FPGA, which stands for Field Programmable Gate Array. So the ASIC is this one. In ASIC, the hardware is developed for a specific application. Let's say you take a mobile phone chip. Okay. If I take my mobile phone and if I remove the chip out of it, okay, I cannot use it for something else. Whatever chip that is going into the mobile phone, it is only used for mobile phone only. It cannot be used as a laptop chip. It cannot be used as a router. You cannot use it as anything else other than mobile phone. There is other domain called as FPGA, which is Field Programmable Gate Array. That same FPGA board can be used for different requirements. The same FPGA board can be used as a mobile phone. Same FPGA board can be used as a laptop chip. You just have to reprogram the things. See, I'll have a board which will have some arrays of standard cells. Okay, logic gates. Okay, by configuring it to behave like an AND gate, this I'll configure it to behave like a. Okay, I can configure it to behave like a OR gate. One of them I can configure it to behave like a NAND gate. So different gates I can configure in this board. Finally, when I configure different points of the board to behave like different gates, you will get the required circuit. Next time when I want a different behavior, I can reconfigure this into different thing. I can erase the existing configuration and I can get a new configuration. That is what is about field programmable gate array. Okay. In this case, what happens? Same FPGA board can be programmed to behave like different applications. That is different types of electronic devices. Example, it can behave like a mobile phone, it can behave like a laptop chip also. Given this difference between ASIC and FPGA, which one do you think is better? Okay, so right now it looks like FPGA is better because it is giving me flexibility to use the same chip as different requirements. But in real life, what happens is people always prefer ASIC for bulk requirements. Let's say mobile phone, which sells in millions of pieces, right? But mobile phones across the world, same model or same kind of hardware will sell in millions of phones. In those cases, companies prefer ASIC style of development because ASIC style of development, the cost per chip will be much lesser compared to FPGA. Though it looks like FPGA approach is better, FPGA is better, industry prefers ASIC design flow. What is one of the primary reasons? Low cost of manufacturing. How much could be the difference? Let's say if I manufacture ASIC, if it costs $10, same thing with FPGA, it may cost $30. So there could be such a huge difference where FPGA will be more costly compared to ASIC. Then you may say it can be used as a different requirements, right? Then why don't we use FPGA? But the problem is, let's say I purchased a television. In TV, there is one chip has been put, right? You definitely know, right? Can I really, assuming that it's a FPGA board only, assuming that it's a FPGA chip, can I take out that? Will I ever take out from laptop TV and use it for something else? No, right? So that is the reason. So it is just gives me flexibility to use it as different requirement. But when it comes to the final application, it will be only one thing. You will not. It's not like you will say that July month I will use it as a TV. August month I'll use it as a mobile phone. You will never do that because if you want mobile, you will go and buy a different hardware itself. You are not going to reprogram that TV chip to behave like mobile phone. So that is the reason there is no real motivation to use FPGA. But anyway, let us talk the difference between ASIC and FPGA in the further slides. If ASIC is cheaper option, why don't we do everything in ASIC? Right? Again, if ASIC is cheap, Why don't we do everything in ASIC? Thing is, ASIC is suitable only for bulk production. Let's say mobile phone, the best example. For this, ASIC is suitable. Okay. For limited production, what is meant by limited production? Something that goes into an aeroplane, right? Will it be manufactured in lakhs or thousands? Thousands only, right? Because you will only have thousands of uh, aeroplanes who will use that hardware. Because of that, all those companies will use only FPGA. The problem with ASIC is initial investment is very high. Let's try to understand the difference between ASIC versus FPGA through cost. Okay, if I take a cost of ASIC design flow, it requires multiple $1 million. Since we need to start from scratch, the ASIC flow, you don't have anything, you have to start from the scratch. Okay, let's say I set up a company, my expense will start from coming up with the design idea, uh, hiring the right set of people to work on that. Third, I have to go and purchase a lot of softwares. Okay, each software itself will cost into multiple crores. So if I have to develop chip, I need different softwares, right? That overall itself, the buying those software itself may become 15 to 20 crore rupees. Okay. That's how costly are the software section. But once the flow is working, once I know that I'm able to manufacture one chip without any issues, per chip cost will be less. Manufacturing cost of per chip will be less once the flow is working. Talking about FPGA design flow, initial investment is less. It will only require lakhs of dollars, much less than ASIC. Why is it cheap? Because hardware is readily available. You don't have to develop the hardware. You have to burn the hardware to behave like your requirement. But what is the problem with FPGA? Per chip manufacturing cost is more. In this case, so the FPGA initial cost, see, you can see the y-axis. What is the initial cost of FPGA? It is lesser. What is the cost of ASIC? Much higher, right? But you can see the slope. FPGA is slant. Slant means what? It increases significantly as you start manufacturing more chips. Your cost will go up drastically. Whereas you see ASIC, it's more flat. That means your biggest cost is the initial flow. Setting up the flow is the biggest cost. Once you have set up the flow, per chip cost will be relatively less. I'm not telling zero, it's not flat, it's not like zero. Cost will be there, but much lesser than FPGA cost. You see, this is the break point where FPGA becomes costlier compared to ASIC. So the people who work in a company, they will do these calculations. It's like they'll do mathematical calculations. Now for me, the market could be 1 lakh chips. We may need to manufacture how many chips? 1 lakh chips. Okay, how much is each chip is going to cost? Okay, let's say $20. They will sit and do all those calculations, and then they will figure out whether to go with ASIC, whether to go with FPGA. In both the approaches, you can come out with the product, same product, working product. Either you use ASIC or FPGA. In both the cases, you can come out with a product which works. ASIC versus FPGA. Any VLSI chip can be developed in either ASIC or FPGA based flow. Decision is based on the overall cost. So I will decide in which case I can do it in a lower cost. Let's say ASIC flow costs $15 per chip, FPGA flow costs $50 per chip. So companies which manufacture for bulk usage, they will go with ASIC. There are around 85% of the companies, 80 to 85% of the companies. Let's say mobile phone sells in millions of units, right? So because of that, which type they will prefer for mobile phone manufacturing? ASIC design flow. Okay. ASIC style of development is preferred. Which companies go for FPGA based production? Okay, aviation based. That is the companies who have a limited manufacturing requirement. Companies which manufacture for limited applications. Example, hardware used in flights sells in thousands only. There they will definitely prefer FPGA. Let us understand advantages of ASIC over FPGA. Tell me, what is the first advantage? Low cost of manufacturing. What is the other advantages? Can you think over it and tell me? In FPGA also you can do. Okay, what is the other advantage? We'll take a simple example. Let's say we are preparing some curry in the home, so we can customize it as per our requirement. Whereas when you go and buy a ready-made one, you have to use it the way it is. Let's say you can't really do much changes to it. The same is the with ASIC also. We can customize ASIC for our requirements. Okay, there are like that many advantages are there. It's not only the cost, there are other advantages. First advantage is what? Cheaper. Second is what? It consumes less die area, hence it is cheaper. I mean, when you manufacture ASIC, you are customizing. Okay, it will consume less area, so hence it will be cheaper. Provide flexibility to customize the design features. I told you, right? You buy a ready-made curry and you make your own curry. You can customize it for your requirements. Power efficient, okay, compared to FPGA, and ASIC can work at higher frequencies compared to FPGA, hence gives a better performance. I mean, what is meant by higher frequencies? Like when you buy a mobile phone, what is one of the things you look at? The frequency of operation. You will see the processor works at 2.5 gigahertz Snapdragon processor. You might see 2.5 gigahertz Snapdragon processor, octa-core processor, like that. The 2.5 is the higher frequency we are talking about. So FPGA cannot work at 2.5 gigahertz, let's say, because it will have its limitations. It's because of the way it's manufactured on the board, and because of the way that FPGA cells are arranged, because you don't have much flexibility with that the connections of all those things, right? They're already pre-implemented, so you don't have much flexibility to control, I mean, do any timing closure at higher frequencies. Whereas in ASIC, since you are doing everything, you can adjust in such a way that at higher frequencies also we can do the timing closure. Now, their FPGA has its own advantages over ASIC. Like in the previous slide, what did we see? ASIC advantages over FPGA. Now let us understand FPGA advantages over ASIC. First advantage is low cost of respin. Respin means what? You have manufactured a chip. Let's say this mobile phone is manufactured with FPGA, for example. Okay, I found some bug in the mobile phone. So my developing a new mobile phone will not take much time, because I don't have to start from the scratch. I just have to take the same FPGA board, reprogram it with a fixed design code. So that is, if a chip has a bug which is detected after manufacturing, FPGA style won't incur big cost. I mean, you won't incur lot of cost. Whereas in ASIC, if there is one bug, to do the entire flow again, it will take multiple $1 million again. Okay. So in FPGA, we don't have to implement the entire flow again. Bugs can be fixed in the another FPGA board. We don't need to start from scratch. In ASIC, if there is a bug, we need to do the entire flow again. And what is second advantage of FPGA? The flow is quick. Means since you have the hardware readily available, you just have to develop your design code and put it onto the FPGA board. So the process will be quick. Since we don't need to start from scratch, board is readily available. It takes less time to develop FPGA board compared to FPGA flow compared to ASIC flow. In fact, FPGA is used in the ASIC design flow also. In ASIC design flow also they use FPGA. That is called as FPGA prototyping. Let's say I'm developing my chip, my own one thing. Instead of completely relying on ASIC only, what I will do is, once I develop my RTL code, RTL stands for what? Register transfer level. Which language is used for this? Verilog. And let's say I put it onto the FPGA board. Okay. So then I will use the FPGA board and run some applications. Check whether that FPGA board is working fine or not. If it is not working fine, then I will fix my issues and again do the same process. So what is advantage do you see there? You don't have to wait for the final ASIC chip to come out. Even when in the beginning stages itself, you can do the prototyping into FPGA. That FPGA will behave very much similar to ASIC. Then you check that FPGA whether it's working or not. If you see some issues, you can fix the RTL and again redo the process. What is meant by FPGA prototyping? Implement ASIC logic onto FPGA board and check the behavior. We can figure out any issues in the design before going for ASIC bulk production. Means instead of me spending multiple $1 million and finally figuring out that there is some issue, I will first check it on the FPGA board whether my logic is working fine or not. If it is working fine, then I will go ahead with ASIC. If not, I'll fix the issue. Again, I'll check with FPGA board. If it is working, then I'll go ahead with ASIC. So first, I can always check the logic onto FPGA. So if the things are very complex, there will be something called as emulation boards will be used. Here I'm just talking about what is ASIC versus FPGA, what is the cost. So in summary, what is these two slides are all about is, if you are going for a bulk production, if your chip will be used in bulk applications, then you go with which application, which type? ASIC. If it is limited application, I go with FPGA. What is the difference between ASIC flow and FPGA flow? See, the VLSI front-end domain flow is similar for both ASIC and FPGA. The front-end domain is similar because in both the cases, user need to understand the specification, implement the design using Verilog or VHDL languages, and functional verification of the design behavior using system Verilog and UVM. So where do ASIC and FPGA really differ? They differ in the backend domain. Majorly, they differ in the VLSI backend flow. The flow starting from physical design to custom layout. The way we do floor planning, the placement, the power planning, CTS, routing, and IR drop analysis. See, whatever the flow starting from synthesis onwards, they differ. Till we do RTL design and verification, both of them are same. ASIC and FPGA flow remains same till we do RTL design and RTL verification. It differs starting from the synthesis stage. Now let us specifically focus on the ASIC design flow. Okay, why did we talk about FPGA? Idea is to tell you that there is one domain called as FPGA. You can explore career opportunities in FPGA also. Instead of just choosing one course, let's say lot of people enroll for physical design. Okay, when a lot of people enroll, what happens? Automatically there is a competition, right? You have to look at domains where there are opportunities, but there are not many people who are enrolling for those courses. Like FPGA is one such domain where there are opportunities. There are companies, let's say you go to Airbus, Boeing, any defense application, defense based companies, they will all use FPGA only. In all those cases, you find opportunity, but there won't be many people in the market for FPGA purpose. Okay, in those cases, I mean, that is where FPGA could be a good option. Now, let us talk about ASIC design flow. ASIC design flow, to understand this, let us take a simple analogy. That is an example of a house construction flow. Tell me, where does your house construction flow starts from? Even before you go for basement, you start with the requirements. What do you want in the house? Without having all those, do you start with the base and foundation? No, right? First you start with your requirements. Then what do? You go to an architect. You sit and draw your architecture? No, right? You won't do anything, actually speaking. You'll only be supplying the fund at different stages. I mean, you'll be spending the money. Everything is done by the other people only. So once you have the requirements, you go to an architect. What architect will give you? Different plans he will give you. Then whom do you go to? Some contractor or some maestri you go to. He will build the basic structure and give you. Will he do entire work? No. Then whom do you go to? You have different people, right? Okay, the plumber, carpenter, painter, tiles person, different people are there. Okay, so and you see there is a specific flow. Will you go to plumber first? No, right? You go to the plumber at the last stages of building, carpenter at some later stages of the building, like that. So like the way house construction has a specific flow, chip design is also very similar, actually very similar. Okay, so requirements and different things I mentioned, right? Can a house be constructed by one single person, entire house? No, right? And can only laborer do without having plumber, without having carpenter? Right? You need different people to finally finish the house. Same way, to manufacture a chip, you need different types of people, different categories of the labor. Okay, it could be labor, plumber, same the way it is. Okay. Even in the chip example, you need design engineers, you need integration engineers, you need functional verification engineer, the DFD engineer, synthesis engineer, everyone is required in it. So ASIC design flow consists of 15 steps divided into two major categories. One is called as front-end domain, one is called as back-end domain. The front-end domain starts with requirements, design requirements, then architecture, RTL design, RTL integration, RTL functional verification. Then finally you do the DFT at the Verilog level. This is the front-end domain. Coming to back-end domain, it starts with synthesis. What is synthesis? Converting Verilog code, whatever language Verilog code we develop, into the gate level format, into the logic gates, is called as synthesis. Once the synthesis is done, then we do DFT at the gate level also, design for testability at the gate level. Then we do physical design. Then we do static timing analysis, what we are calling as timing verification. Then we do custom layout, physical verification. Then once we do the physical verification, okay, right now don't really worry about all this. You probably won't know what is meant by physical verification. You probably won't know what is meant by STA. So don't worry. It is not expected for you to understand everything. We are trying to understand the flow at the top level. Okay. Then finally, once you have done physical verification, what is the next stage? GDS2 extraction. What is GDS2? Can someone explain? Sorry, it is the file that we give to the foundry. Okay, let me give you a simple analogy to understand this. Okay, one movie is there. For me to watch that movie in my mobile phone, my laptop, What is the extension that I need? .mp4. So that .mp4 got created after a lot of process. What is the process? You know, the film production is there, right? Lot of process it went through. Finally, what is the format in which they are releasing it to the people? .mp4. Same way, after going through all this process, that whole information is present in something called as GDS2 file. What is GDS stands for? Graphic Design System. Now, at a very top level, what is that graphic design system? Is very simple. You have got a silicon wafer like this. That graphic design system will tell where the doping should be done, where the metal should be deposited, where the oxidation should be done, where the etching should be done, how much doping to do. That will tell. You may say it's very simple, right? Where does the complexity come is? You are talking about doing it for 100 crore transistors. We are doing it for how many transistors? 100 crore transistors. For each transistor, they have to tell where the doping should be done, where the metal should be deposited, where the etching should be done. That whole thing for each and every transistors. That's what makes it whole complex. Not only that, you're talking about 3 nanometer technology. 3 nanometer is very, very small, right? At that level, if you have to manufacture with so many things, it is the complexity. That is why you see setting up a manufacturing fabrication unit takes almost 75,000 crores, lot of money intensivities. Once you have GDS2 file, what do? It goes for fabrication. Then we do post silicon validation. I will explain what is post silicon validation in a slide later. I mean, here if just I have to explain in brief. Once the chip is manufactured, fabricated, before putting into the final electronic product, it is being tested. The chip itself is tested whether it's working fine or not. It may not work due to some manufacturing defects. Inside, when you are manufacturing at 3 nanometer level, there could be some defects, right? To figure out those defects, we use there will be a person called as post silicon validation engineer who checks that whether the chip is working fine or not. So finally, what do? Once the post silicon validation is done? Packaging. That is where you get this mobile. Okay. Next, let us briefly talk about VLSI front. We'll talk for another 10 minutes and go for a break. Let's now talk about VLSI front-end domain flow. VLSI front-end domain is similar to software flow. What is the skill set a software engineer requires? C, C++, Java, coding expertise he needs. Similarly, a VLSI engineer also requires programming skills. Software engineer should be good with reading the software specifications, right? How the software behaves, everything. And based on that understanding of the specification, they should develop algorithm and implement the same using languages like C and C++. And they should have good programming skills. Similarly, a VLSI front-end domain engineer should be good with Verilog, system Verilog and UVM, should be good with programming or have inclination towards programming. They should also be good with reading the design, hardware design specifications and understand the design functionality. Implement the requirement using various protocols. Like protocols are like USB, PCI Express, DDR, AMBA, different things. So here, see what is similar to algorithm is protocols. A software engineer needs to learn algorithms. VLSI engineer need to learn protocols. Similar to C, C++, Java. Similar to software specifications, hardware design. Both requires programming skills. Okay, majorly the problem with the people who join the courses is they think that they are not good with programming, and they most of the time end up taking back-end courses, specifically physical design. But I would seriously suggest you to try this domain, even if you are not good right now with programming, because you haven't done it for last 3 years. If you are from electronics domain, you would have done uh, programming C language sometime in the first year, right? First or second semester. But it's a very good domain to be in. Okay, why it's good domain is uh, it's like a almost evergreen domain. Every time, even during the recession, we were able to find the job opportunities. Even during the recession, companies were hiring. Okay. And it's more relaxed than backend domain. In physical design, many times, if you know any senior or any friends who are working in the industry, if you ask them regarding how does a physical design engineer work profile will be, sometimes they will have to work late night, 2 o'clock, 3 o'clock also. It is because why it happens is, if the project starts in January, let's say it goes till October, assume. Okay, let's assume a project which starts from January to October. The front end domain work will be spread throughout. This is front end domain. Someone who works into back end domain, their work starts here. Somewhere in the middle it will start. So you see their work is almost towards the end of the project. They will have a lot of stress actually, because initially, even if you go little slowly, nobody bothers. But when the August and September comes, people will start asking, because they have to release the product by October. So they'll have a lot of stress due to that. And also you see all the work they have to done in 2 to 3 months, whereas a verification engineer does it over 6 to 7 months or 7 to 8 months, which is more relaxed compared to backend domain. Okay, so because he is not having any work, they won't keep him free. Backend engineer will not be free during January to May. He will be into some other project. So that way their work is relatively more stressful than front end domain, especially the girls, right? I would seriously suggest front end domain, because back end domain is more challenging in terms of the requirements. I mean, the effort that you have to put and all that. But unless you are passionate, let's say you are passionate about physical design, you are passionate about DFT, then you should go. Otherwise, if you are open to decision making, I mean, it could be anything. I'm more concerned about a job. Front end domain is a good domain to be. Okay. So fine. We have seen in the previous slide, we have seen how VLSI front end domain and software are similar. Let's understand where do they differ. In summary, they differ in the backend domain. In software, there is no backend domain. Got right? In software, there is no backend domain. As soon as you develop the software, once it is tested that it is working fine, you don't go for any fabrication. You directly install into the electronic product. Let's say I have an application which is tested. I can directly install that application and start using it. Whereas in hardware, once the hardware is manufactured, once the code is working fine, you have to manufacture it to use it. That is the primary difference. So software doesn't require backend domain flow. Okay, in VLSI, functional verification plays a very important role. If there is a bug in the chip which is detected once it is in production, let's say already your mobile phone is getting produced, is in the production stage, that means people are buying it. At that time, if you detect any bug, what will happen? You cannot fix the chip, you'll have to redo the entire flow. But in software, what can be done? You can fix the bug, we can release a patch, you can fix the bug and release it as a patch. That is the advantage. I mean, that is how VLSI and software differs. Okay, the bug can't be fixed in VLSI. The entire flow needs to be done again. VLSI chips don't have a concept of patch. Okay, if you have a bug, you cannot release a patch and fix the bug in the chip. Whereas in software, if there is a bug, it can be fixed easily, can be released in a new version of the software called as a patch. They keep releasing patches, right? Now let us take a break. Okay, we will meet in another 10 minutes. Okay, and then once we meet, we'll continue with the VLSI domain and different job roles, and whatever is the remaining topics we'll talk about. And also, once we are done with all this discussion, I'll do question and answers. I mean, if you have any questions, I'll help address those.
This conference will now be recorded.
So let us resume the session. So before the break, we were discussing about VLSI domain and what is front-end domain and what is back-end domain. We also understood how the front-end domain is similar to software flow. So by now you'd have understood that if you want to get into front-end domain, okay, you should be comfortable with programming. Okay, you should learn languages like Verilog, System Verilog, and UVM, and you should be good at reading the design specification. Okay, and understand and good with debugging skills. I'll explain everything as we go forward. Now let us talk about different job roles in the VLSI domain. In front-end domain, person who works on design requirement is the marketing team. The person who works on architecture is the chip architect. Person who does RTL coding is the RTL design engineer. Person who does integration is the RTL integration engineer. The person who does functional verification is the functional verification engineer. The DFT at RTL level, it is DFT engineer. Then you have synthesis engineer, the formal verification engineer. Then you have DFT at the gate level, physical design engineer. So like that, for different activities, there will be dedicated people will be there who works on those. As I said earlier, the person who works into, let's say, DFT, he will only be responsible for DFT. Okay, he will only be responsible for DFT. 1 second. Others also facing issue with my audio. Okay. So like that, there will be a dedicated person who does these activities. Okay. Uh, so most of the career, if you decide to work in a specific domain, you can make the career in the same domain. Let's say I decide to do DFT. So starting from the time where I start my career until the time I retire, I can only be doing DFT work. There will be so many opportunities in that domain itself. I mean, in the technical ladder itself, you can grow. You can start as an engineer, senior engineer, lead, staff, principal engineer, like that you can go. If you want to get into manager role after certain stage, you can move from DFT engineer to manager role also. All that is possible. So the good thing is you don't need to learn everything here. So in summary, what is the expectation in the job will be when you go will be, let's say you are learning functional verification. You should be very good with this. A very basic idea about these things. Basic idea about what does a physical design engineer does, what does DFT engineer does. That basic idea is what is required. But one specific domain you should be expert. Next, ASIC team distribution. Typically assume that one team has 50 people. Okay. How the team of 50 people will be distributed? Front-end domain will have around 25 to 30 people. That is around 50 to 60% of the people will be in the front-end domain. Then what is there in the back-end domain? Around 40 to 50%. So out of the 25 to 30 people, one person will be the architect. There will be only one architect. Around 4 to 6 people will be design team. 4 to 6 people will be design team and integration team. Then we'll have remaining 15 to 20 people will be functional verification. So you see which domain in the front end has more opportunities? Functional verification, because almost 20 to 30 to 40% of the entire team will only be functional verification. That is where you see lot of opportunities in this domain. And because there are so many jobs are there, companies hire freshers also for this. See, architect, will they go with a fresher or experienced person? Experienced. Again, if I take design team, will they prefer going with fresher or experienced? More experienced, because they need only less people. They're okay to go, they're prefer to go with experienced people. Whereas since there are more opportunities here, more requirements are there, they will take a mix of experienced people, they'll take a mix of freshers. Talking about backend domain, it will require around 20 to 25 people. DFT will be 2 to 5 people will be required. Physical design team will require around 10 to 15, which is around 20 to 30%. STA will require 3 to 5. Layout will require 3 to 5. That is where there are two domains in VLSI where you will see a lot of opportunities for freshers. One is the functional verification, one is the physical design. There is a DFT also where the fresher hiring happens, but not as much as other domains. Okay. Next. Since some of you are attending DFT also, I will just, if any of you are here or attending online, let's take a quick overview of what is DFT is about. Okay. DFT stands for what? Design for testability. See, chips can have different types of manufacturing defects. When a chip is manufactured, it can have different types of defects. If it is working fine, it's good, no defect is there. But a faulty chip can have different types of defects. Those defects are like stuck at zero fault, stuck at one fault. What is meant by stuck at zero is some wire in the chip is always at zero voltage. Whatever you do, it never moves from zero level. That is at stuck at zero. Other one is what? Stuck at one. There will be something called as at speed faults. Okay. The role of a DFT engineer is to develop something called as test patterns, which help detect manufacturing defects in the chip. Using those test patterns, we can detect manufacturing defects in the chip. Okay. So how does it work? The chip is there. These test patterns will be applied. Based on the output comes, whatever is the output, we check whether it is good or it is having some defects. The person who develops these test patterns is called as DFT engineer. The person who does this work of applying, checking is called as post silicon validation engineer. It is not the role of DFT engineer is to check the chip. His only responsibility is to provide the test vectors. His responsibility is what? To provide the test vectors. Let's say one of the test vector sample pattern is like something like 1 0 1 0 1 0 1 1 1, like this. This pattern is what is driven into the chip. These numbers, okay, through a port, okay, it will give an output. These are not like randomly generated. It's not like they throw a dice and generate 1 0 1 0 anything. They have a meaning. Why it is 1 0 1 0, why it is 1 0 1 1 1. There is a meaning for that. Okay, when that is applied to the chip, the output will tell whether the chip is good, chip has some defects. This pattern is applied to the chip. Chip output tells whether the chip is good or faulty. DFT engineer uses various techniques to generate above test patterns. It is the DFT engineer who generates above the pattern. That means who provides this pattern? DFT engineer. What is the techniques he uses? Techniques like scan, ATPG, automatic test pattern generation, built-in self-test, JTAG, boundary scan, compression. Different techniques are there. So he uses these techniques to generate a patterns. Those patterns are applied to the chip. And the person who does the checking is called as very post silicon validation engineer. These test patterns are provided as input to post silicon validation engineer. Is anyone facing issue with my audio? Is it low? Okay. So the post silicon validation engineer applies those test vectors on the chip using a tester. Okay. Output of the chip indicates if it is okay. One more thing, if you are connected, those attending online, there is an option to make it full screen. I think F11 or something you have to make it. Can you try F11? Or in the which screen you are seeing, there will be one menu called as hide everyone. In the top middle, there will be one option called as hide everyone. You can do that one. So the output of chip indicate whether if it is working fine or not. Okay. If there are defects, the chip is not used for packaging. What is post silicon validation engineer? The post silicon validation engineer takes the test patterns from the DFT engineer, applies them on chip, and verifies the chip behavior. Percentage of good chips is called as yield. Let's say I manufacture 100 chips, 90 are good, 10 are bad. So my yield is 90%. Out of 100, if 82 are working, the yield is 80%. 82%. Okay. Next. So this is a brief about different domains. I'm not going to talk about physical design. I'm not going to talk about STA and all that, because if you want to understand what is physical design, what is STA, tomorrow's demo session you can attend. That will be on VLSI backend domain flow, where the trainer will more specifically focus on what is synthesis, what is physical design, what is layout kind of topics. Okay. Yeah, Lohita, please ask your question.
Sir, here we mentioned the DFT in the front end and the back end also. What is the
Right.
difference, sir, in that?
Basically, DFT is all about what is DFT. I'll tell you. Uh, if you have a chip consists of some flip flops, right? Chip will have some flip flops inside. What DFT engineer does is he converts it into this normal flip flop into something called as scan flip flop. He will add few signals called as scan input, scan enable. Okay, like that he modifies the existing circuit to make sure that it is easy to verify the chip. Chip is very small, right? Let's say if I give you this kind of chip, small chip which is 1 centimeter, 1 centimeter, very small one. Can you, just by looking at the chip, can you tell this is good or this is corrupted? You cannot tell, right? You need some kind of techniques. So that techniques is the DFT techniques. What also they parallelly do is they change the circuitry itself little bit. They insert something called as BIST logic, built-in self-test logic. Means my mobile phone itself will have, my mobile phone chip itself will have some testing logic inside it. So this logic update can be done both at the RTL level, that is at the Verilog coding level, as well as at the gate level. So when you do at RTL level, that is the DFT engineer is working at the RTL level. When you do at the gate level, he's working at the gate level. So that is where the DFT engineer works both at the RTL level as well as the gate level. You understood, right? Basically, to verify a chip for manufacturing defects, you need to modify the logic a little bit. You need to add some circuitry called as built-in self-test. Also, you have to change the normal flip-flops to scan flip-flops. There are some changes that need to be done. Those changes, some of them are done at the RTL level, some of them are done at the gate level. So hence work happens at both the stages. Okay. So this is about little bit about different aspects of the flow. Now let's come to the training schedule. Okay, I'll be more focused only on the front-end domain related trainings. Okay. Mode of training, we have a training, full week training as well as weekends only and weekday evening batches, but it is currently we have not been offering because we need minimum enrollments for these batches. Talking about full week, it is online. It is, you can attend online, you can attend offline, you can even attend hybrid model. Hybrid means partly online, partly offline. What is mean by that? Let's say first 2 months you want to attend from home, then you want to come to institute and attend offline. That is all possible. So you have completely flexibility to attend the way you want. In this mode, in full week, you will have training for 6 days. I think I'll talk about that also. Recorded video access for 2 weeks for every session. Let's say today's session, this is being recorded. This video will be accessible for you for next 2 weeks minimum. Sometimes we keep extended access also. Okay. Next. Coming to weekends only batches, this is mostly meant for working professionals because they will not have time to attend during the weekdays. They will be having sessions on Saturday and Sunday for them. These are online sessions, dedicated mentor for offline doubt clarification. You will have access to all the recorded videos of for entire course duration. Because they're only attending weekends, right? So we, instead of 2 weeks, they will have access to all the recorded videos for entire course duration. A weekday evening batches is generally, it is only when we have minimum strength. We should have minimum strength of 10 people to do a batch. Then we can offer even weekdays evening batches also. In all modes of training, a student is assigned with a dedicated mentor for doubt clarification. So what is the first thing we do is we create a dedicated WhatsApp group for each student. Let's say there are 30 students in a batch. For each student, there will be a dedicated group where you can post your support request. It can be technical, it can be non-technical. So that if it is technical, our trainer will connect with you and help clarify your doubts. If it is non-technical, our support team, admin team will support you with that. Next, talking about functional verification training for freshers. It's a 8 months course. Okay, we purposefully made it long. Okay, even though it's 8 months, you can start getting placement support from the 6th month. You don't have to wait for 8 months to get a job. Let's say you start in January, from June onwards, you start applying for the job. Then why 8 months? What is the purpose of 8 months is to make sure that we give you that industry level project exposure. We'll have 6 days of training per week. Sunday will be off. Around 4 to 5 hours per day. This 4 to 5 hours will have 2 hours of theory, 3 hours of labs will be there. In a day, we'll be doing 2 hours of theory and 3 hours of lab session will be there. It could be half an hour here and there. 1.5 theory, 1.5 hour theory, 3.5 hours lab. That is also possible. Typically, we try to keep the sessions in the first half, 9:30 to 1:30, but sometimes sessions can also happen after the lunch because it's not possible to do everything in the morning only. Like as I said, 2 hours theory and 3 hours of lab session. Every session recorded video access for 2 weeks. We have our own learning platform called inskill.in. It is the e-learning platform where all the course presentations, assignments, and notes are uploaded. So if we go to a portal, if I take any course, let's say System Verilog, if I take, okay, you will have access to this portal where you will have access to the videos of the live batches. Presentations will be accessible. Whatever presentations we do, that presentation can be accessed from this portal. Other than that, it is taking time. I mean, you can access from here, and also we provide the hard copy of the course material for everyone who enroll for the full course, the full 8 months course. We provide the entire course material as a hard copy. Even if you are attending online, we send it by post. Other than that, you can access the assignments here. Assignments also will be present in the course material, that hard copy of the material we provide. And you can get notes and whatever notes I prepare. Generally, you see, while training, I'm writing some notes. Okay, not only me, my all other trainers have this habit of developing, making a notes and sharing with the student. That also you will get access. This is about it. Printed course material provided for all modes of training. Even if it is live training, e-learning course, online course, you will still get the course material. Functional verification training, which I said 8 months, it is divided into 3 phases. Phase 1 will be for 3 months. Phase 2 will be for 3 months. Phase 3 is for 2 to 2.5 months, around 2 months. Okay. Phase 1, which is in which will cover advanced digital design, Verilog language, and Verilog design projects. We'll also cover GVim text editor. All those things will be done. Phase 2 will be doing system Verilog and UVM. Also, we'll do Linux commands and soft skill training. This is where the placement support will start. Okay, once you are done till this stage, your placement support will start. Because when you go to the interviews, the companies expect this skill set for interview purpose. Phase 3 will be focused on multiple industry standard projects. The projects on standard protocols like AXI, AHB, APB, Ethernet, MAC, these kind of projects. Also, we'll teach Python scripting. We'll also teach SOC flow concepts, flow basics. Okay. In this period, the phase 1 and phase 2, the first two things will help you in getting the job. The phase 3, the one where you do the industry level project, that will help you perform in the job. Okay. In most of the other institutes I know, their training stops after this one. Okay, they teach very good digital design, they teach very good Verilog. I don't want to say that they don't teach well, all that teach well, but the limitation you find in other institute is the time is the limitation, where they have to finish the course by 5 months or 5.5 months, 6 months, mostly because they'll have limited rooms, uh, in which they have to accommodate multiple batches, right? So they have to finish by 5.5 months to accommodate newer batches. Here we have more training rooms that gives us flexibility to do a longer duration courses. Okay. That is where you find the gap actually. When you go to the industry, now even if I tell you, probably won't be able to understand what I'm telling. This one is more important for you to work in the industry. When you get into the job, you probably won't need very in-depth of SV, very in-depth of UVM. But for interview purpose, yes, they will go in-depth of each and everything. But once you get into the job, the flow you should be very good. I mean, how the verification happens, how the test cases are developed, how the debugging is done, how the coverage analysis is done. Something you have to learn by doing one project. That is what we do as part of the phase 3. Okay, that is the most important point where you are going to learn the things. Okay. What I see is, since they don't have much time, they do a smaller project which won't be in line with the industry requirements. Now, talking about functional verification training for experienced engineers. It is for 6.5 months. There won't be any, as I told you, right? Verilog and system Verilog won't be there. It directly starts off with what? System Verilog and UVM. UVM will have both main and advanced. Phase 2 will be 2.5 months. Where we do the same, whatever projects we did, right, for the freshers, same thing will be done. So what is the difference? As I said earlier, this is additional, no digital, no Verilog. This is what is experience courses. Let me give you a brief about what is functional verification. I mean, you see, we have been talking about functional verification, right? What exactly is functional verification? I'll talk about brief. I'll explain it through one of the examples. I take this design. What is this design? Ethernet MAC. In this design, it has almost 35 files. You can see these are all the files which are meant for Ethernet MAC behavior. These are coded in which language? V means Verilog language. If I take one of this code, you just look at line number 222, that this line, sorry. Please take a look. You probably won't understand what exactly is it. Let's say during the coding, I've done a mistake where I have removed, what is this kind of operator is called as? Bitwise inversion. Bitwise inversion. If I remove this one, I remove that bitwise inversion. Will it work? If I remove the bitwise inversion, will this code work? It won't work. Now, if I tell you where is the bug, can you find it out? Can you find out the bug? No, right? My point is, if I am a design engineer who develop this Verilog code, I don't do mistakes intentionally. I will not tell that let me keep a bug in line number 200. Let me keep a bug in 250. I won't do that. While coding, because of for whatever reason, my wrong understanding of the behavior design, or for some reason, I end up doing some mistakes. Okay. What will happen if this mistake is not detected? Let's say this Ethernet MAC, this mistake is not detected. What will happen? That will go into the physical design flow. When you synthesize, that mistake will come into the gates also, right? Okay. And that mistake will finally get manufactured into a chip. When I use that chip in my laptop, some features will work related to Ethernet. Some features won't work. Why they don't work? Because some logic is wrong. One part of the logic is wrong, other part is good. So as a user, even if out of 100 one feature doesn't work, will you use that mobile laptop? Same problem happens. See, due to this bug, okay, everything won't stop working. Not everything stop working. Lot of things will work, few things will not work. Okay. So the role of a functional verification engineer is to detect this kind of bugs. There are two ways I will suggest. One is he opens each file, goes through each line and tells this is good, this is bad, this is good. That is one approach. Second is he follows a process where takes a design, has a reference model, his own model, where he applies some inputs, same inputs applied here. He gets the output, he gets actual output from the design, compare both of them. And if output matches, it is good. Output doesn't match, there is some fault in this. So we are talking about two approaches. One where he opens each and every file, goes through each line and tells this line is good, this line is bad. Second is this approach, where you create your own model, apply the inputs, you get actual output here, you get expected output here, compare them. Which approach looks more scientific? First approach or second approach? Second approach, right? Because in second approach, you are giving some inputs and checking the output, comparing the output. In the first approach, you don't know what is the intention. I mean, even if I miss this, instead of this and, if I make it or, I really don't know the logic at this level. Why they have used AND gate, why they didn't use OR gate, I don't know. So I cannot really debug at line by line level. So that is where we follow a process called as functional verification flow, where I explained you, right? We develop a test bench, through that we verify the things. So that is the role of a functional verification. You understood what is the role? What is that? Okay. Similarly, like if I take any code, right? You take this code also, receive control. This code is different completely. So this code is different from earlier one. Some mistake is done anywhere. For example, let's say here instead of and, I made it or. I'm not telling that only this kind of mistakes will happen. There are many other mistakes can happen. Okay. For example, this line itself is missing, some or other reason. So the role of a verification engineer is to catch these kind of issues in the design code. Similarly, for those who want to join for FPGA course, it's a 6 months course, 6 days per week, same thing. Training is divided into 3 phases. Initial phase 1 will be same as normal functional verification flow. Whatever you are doing functional verification, 2.5 months will be exactly same. Later 2 months will be FPGA flow in depth, FPGA boards, standard protocols, Linux commands, soft skill training, they will be there. And the last 1.5 month will be actual implementation of the FPGA on the FPGA board. Here phase 1 and phase 2 helps you, same thing, phase 1, phase 2 helps in getting job, phase 3 is where you actually learn the core FPGA flow. Regarding the DFT training, so today at 4 o'clock when you have the demo session, you attend that, you'll get an overview of this flow. Next, how to choose the right course. With so many domains, how to choose the right course? A simple thing, if you are interested in programming, if you are okay with programming kind of job, go for front-end domain. If you don't want any programming at all, go for back-end domain. You can also look at FPGA as a one option, where you don't need in-depth of programming, because generally as a FPGA engineer, even if you learn till Verilog, okay, learn till Verilog very well, even if you don't know system Verilog and UVM in depth, you can manage, because once you do Verilog, you need to implement the FPGA system design flow. So there it requires a medium level of programming. So functional verification requires good level of programming expertise. It also has good opportunities. FPGA has medium level of programming expertise, but you should have expertise of working with the FPGA flow. You should develop. And backend domain, physical design, DFT, STA, custom layout, they don't need any programming at all. Requires no programming expertise, mostly tool and technology oriented job. Our institute provides flexibility where you can join any course. You can switch to any other course up to 2 months without any additional fee. Let's say you join front end because I suggested, you joined. After 2 months, you figured that you are not comfortable with programming. We'll give you option to switch to other domain without any additional fee. Okay. So you don't need to repeat entire 2 months in the new course. Initial 1 month is common. Whether you join front end or back end, 1 month is common for everyone. So at that point, when you want to repeat, you don't join from the beginning, you join into the next batch uh, uh, from topic starting after the 1 month. So that 1 month topics you missed, right? That point onwards you join. So initial 1 month is common for all the courses. So you join the next batch of the training where 1 month topics are covered. So this flexibility is there. You can join after 3 months also actually, but 1 month specific additional charges will be charged. Means after you join now, after 3 months you can come back and tell that I want to switch. That is also possible. But we may charge you, let's say 6,000, 7,000, some amount, so that you can switch to the other domain. But up to 2 months, there won't be any cost for that. Next, preparing for the job. Actually, okay, by now you would have noticed that. I mean, after seeing all that, you are freshly out of the college, you might have seen impact on the campus placements and all that, right? Probably it's not as great as what it was 2 years back, 3 years back. So that means that you have to understand that you have to put a lot of effort now. Okay, there are opportunities in the market. Companies do hire. Even I can show how the placement happen in the institute. It just that company won't hire because you joined a training institute. Means just because you joined an institute, I cannot give you job. Companies will hire only if you are worthy of job. Let's say Wipro comes. Why will they hire? If they feel that when they hire, you can perform some activities, their work, only then. So you have to reach that level where you can give an activity, you're able to work on it. They don't expect you to do very complex things. You don't need to do research and development. You don't need to develop entire chip. Small activities, some activities they will give you as a beginner, as a fresher. You should understand what is that activity and you should be able to work on that activity without lot of support from the seniors. I mean, you should not go to your senior for every small thing. What is this? How to code this? How to read this? Then they will only do, right? If they have to support for small things, they will only do. So the whole purpose of training, more than giving you a job, what should be the purpose of training? Tell me. To fill that gap. See, right now you're after passing out from your BTech engineering, right? You don't have that complete skill set where you are able to work in the industry because your mostly learning has been theoretical. Industry wants more practical exposure, coding based exposure, okay, debugging exposure, which you don't get in the colleges. So training is to fill that gap, also to help learn the fundamentals, because during your college days you may not have got the required fundamentals with digital electronics, even Verilog programming, those things. Training is to fill all that gap, prepare you for the job. Once we prepare you for the job, I'm not telling go and start searching your own job. We will provide, but main focus of the training is to enable you to come to a point where you are employable, where companies are okay to hire you because they know that you can perform a job. Okay? That is not a one-sided effort, right? I mean, only if I teach will it happen? No, right? You'll have to put effort. How much effort? No need of 14 hours, no need of 15 hours a day. A good 8 hours a day is sufficient. 8 to 8 hours. If you do, after 6-7 months, I'll give you job. Every day you tell me that I'm spending 8-9 hours, quality 8 hours, where I am not thinking about anything else. No WhatsApp, no Facebook, nothing. Okay, I'm only focused on that 8 hours only. Remaining, you sleep, you eat, you whatever you do, no problem. If you do that much regularly, you can easily manage a job after 7-8 months. Easily. Most of the time people don't get because somewhere they lose that focus. After till 1 month they will be very serious. Even now there, let's say there are 40 people. By the time I reach 6th month of training, that 40 becomes 15. The same 40 strength becomes 15, not because we our training is not good after 2-3 months. At every stage we have a good trainer to handle the corresponding topic. Somewhere students lose that motivation, lose their confidence level, where we proactively tell them that if you need any support, you come to us, we'll support. We have a dedicated team, dedicated person who is meant for quality management. She will keep tracking in this batch 40 people are there, how each person is doing, how many assignments he has done, where he is lacking. That level of support is also provided. Okay. And why he didn't do, what support he needs. Because when we run an institute, see, for your engineering college, even if they don't get much placements, college will run. For us, quality of training is very important, because that is what gets us the next level of admissions. Okay. So hence, and also the more importantly, more than admissions and anything, what I personally believe is this is your last stage of formal education, last phase of formal education, right? Because after that you are not going to go into education. After that you join the job where you start earning the earning. If you do some mistake in school, some education, let's say your elementary school was not good, it will be corrected in high school. If some mistake happened in high school, it can be corrected in PUC, that is +1 +2. You can still correct in engineering college. If something is missed in here, you don't have a chance to learn other than learning yourself. So we understand that part of it. So we focus on multiple aspects, not just technical part of it. Soft skill training will be there. The purpose of soft skill training is to make sure that your the gaps are filled. With respect to the basic communication skills, how to speak, how to face the interviews, and how to write emails, how to attend the interviews. All those things will be covered during the soft skill training. It is not like a 1 week training which happens to the end of the year, end of the training. It will happen every week. Every week, 1 or 2 hours soft skill training will be there. Only request from my request to the students will always be that you should proactively participate. Okay. Let's say my trainer may ask you, soft skill trainer may ask you, she will give you one topic and ask you to prepare on the topic and come and present. Just talk to the people about the topic. You should not feel shy. You should not feel worried about things. You should just confidently do it. That kind of proactiveness is required. And the other thing is willingness to learn and willingness to put effort. Okay. So that is what this slide will be all about. So preparing for job. Okay, now talking about our institute course, what is the difficult part of training at VLSIGuru Institute is the things move quickly. See, by the time you realize that some topic is happening, within 3-4 weeks the topic is completed. What do I mean by that? You take digital electronics. For you, during your BTech, digital electronics happened over entire semester, right? 4.5 months or so. So you have time to prepare that for entire semester. Whereas in the institute, what happens is we finish that in maximum 3 to 4 weeks, and lot more than what you did in your college. In your college, you would have studied mostly basic logic gates, basic D flip flop, JK flip flop behavior, excitation table, truth table. That's where your learning stops there. Whereas here, we learn a lot more things than what you did in BTech, and more specifically, it finished in 3 to 4 weeks. During that time, we won't touch any other topic, only digital electronics. So you should learn to focus on one topic and try to be in sync with the trainer. That is what I meant by things move quickly. Again, I'm repeating, you don't have to spend 15 hours, you don't have to spend 12 hours also. A good 8 hours. What is that 8 hours include? The time you spend in the institute also. Let's say you spend 5 hours in the institute. I'm only asking you to spend 3 hours at home. If you do that every day, you can get a job. Even if there is AI is there, whatever is there, you can still get a job. You just have to tell to yourself that every day I have to spend quality focused 8 hours. Okay. So what we would learn in 8 months of our training is almost similar to your 2 years of things you learn in BTech. That much amount of knowledge you will gain over 8 months of time. Okay, 3 weeks of fully focused digital design. Contents is more than what you do in BTech, but that gets over in shorter duration. Like that, for every topic we do, we have to go in depth. See, I cannot teach you at top level. When you go to the interviews, they check fundamentals in depth for every topic. we also do performance tracking. I mean, quality management, what I call as in the institute, we call it as quality management, where in a batch, we keep track of each and every student. We keep track of how you're doing with assignments, evaluation test, mock interviews, okay, some presentation session. Like you will be given a topic, our soft skill trainer will give you a topic. It could be any generic topic or whatever training we are doing, okay. You will be asked to make a small presentation and present it to the people. That is where the problem starts for us. Out of 40 people, 20 people will not come at all to the class. I mean, somewhere they fear, somewhere they don't want to do. That is where their problem starts. My approach is, even if you don't do anything, even if you come with an empty presentation, at least have a guts to do some presentation, one minute presentation, 1 or 2 slides, so that your process starts, your learning process starts. Other day, my soft skill trainer was telling the same thing to me, that out of a batch of 40-50 people, only 10 to 15 people come for that. Oh, once you stop coming, I cannot do anything. The institute, it's not like a school where teacher will beat student, and that also doesn't happen now, right? Here the trainer will have a limited control on what to do with the student. We can only motivate you, we can only help clarify your doubts, or we can give you the right guidance, okay. Beyond that, it's all in your hands, okay? So we categorize the student into good performing, average, poor performing student, and provide the required support. So what kind of support can be there? I'll tell you example. Let's say you finished Verilog, but at the end of Verilog, you are not good with Verilog. Some basic things also you are not able to do. Okay, you completed whole Verilog, but you don't know how to code multiplexer. Okay. So then what is the best solution there? We won't promote you to system Verilog. We ask you to repeat system Verilog course. Okay. Sorry, we ask you to repeat the Verilog course. So like that, we suggest time to time. So in those cases, what is the problem for you? Your course gets extended. So we are not going to charge you for repetition, but we will be tracking your performance, and accordingly we'll be suggesting you what to do. Performance will be tracked based on how you do in the assignments, what your attendance, your evaluation test results, and presentation and mock interviews. And as I said, there will be a dedicated WhatsApp group for every student where you can post your request, what support you need from the institute. In that, trainer, admin, and student will be there. What is the final goal of 8 months of training is, student should be enabled to work in the job independently. I mean, once you complete the training and join a company, you should work independently. You should not go to your senior or a lead engineer for small supports. You should become not only about technical things, not only about SVUVM, it's also about how do you write an email, how do you talk to the other people. That whole thing has to develop here. That is where we don't only provide the technical part of the training, it's also soft skill training which gets included in this, okay. So this is all about, and it's a collective effort where I alone cannot do that. My soft skill trainer cannot do, my other trainers cannot, only alone cannot do that. Student has to put effort. 30% effort is from the institute. I would say a lot of 70 to 80% is from the student only. Again, let me repeat one more, two things you have to keep in mind. Throughout this 6 months, I'm not even telling 8 months, 6 months only, because at 6 months itself, you can get a job. If you do well for 6 months, you can get a job. Okay. You finish 80% of the course assignments. Very good chance that you will get a job. I mean, I can even almost give you 100% guarantee that you will get a job. Because once you complete 80% of the assignments, you will have a confidence on your knowledge. I mean, you can see that you have learned the things required for you to work in the industry. Second mistake, one of the mistakes students do is they forget the things. I mean, it's natural, right? What I have learned in January, will I remember in July? No, right? So you have to make a habit of revising the things. Let's say in first month, what is the topic we do? Digital electronics. The person would have done all the assignments also. Person would have learned. Today I'm teaching comparator. I'm teaching subtractor, full adder, half adder, flip-flop, counters, everything. But the only problem is, even if I've learned properly, after 3 months, I won't remember much. After 3 months, if I ask you to draw a 2-bit comparator, you cannot do. So that is where revision is very important, very, very important. Because when you go to the interview, when they ask you some question about comparator, let's say in digital electronics, you cannot say that I did it 7 months back or 6 months back, now I don't remember. Can you tell that? So that is where you have to make a habit of revision. That is where you have to develop a small notes for entire digital electronics. You have to make a 3-4 pages notes, small points, important point. And time to time you should keep revising. Time to time you should keep doing some questions. That's after 1 month. You should still take some 5-6 questions of digital and do that. Same thing for Verilog. System Verilog you don't need to do, because by the time you reach System Verilog, you are already preparing for the job. So digital and Verilog you have to keep revising. Okay. These are the few things you have to keep in mind. The third thing, first thing, what is the first thing I said? 80% of the assignment. What is second thing? Prepare notes and keep revising. Okay, not that every day a full day you have to revise. At least half an hour in a day or 2-3 hours in a week, you just revise so that you don't lose touch with the subject. Okay. Third thing is, for keep up your motivation. Don't just prepare with a job as a mind today. Think about job only after 5 months. For first 5 months, only focus on becoming how can you be an expert. Okay. The fourth thing, wherever you join, let's say you join here, you make a group of another one person, 2 people, not more, 2 people, very important. Because you can, as a group, what can happen, as a group of 2 people, you can keep some timelines and you can try to meet those timelines. Let's say you have a doubt, you can discuss with the other person. You can intermediate, I mean, each other you can ask some questions. That level of preparation is really required. Again, the fifth thing you need to remember is, just you join a course, just join your institute and you pay the fee, you are not getting job just because of that. You get a job only when you learn the things as per the company expectation. I am not the person who is going to hire you. It's the companies who are going to hire you. Your knowledge should meet their expectations. And they are not expecting you to come with very high skill set. They are not expecting that you will do entire chip. You will do some research and development. Their expectation is realistic. That much you have to meet. Okay. So that is about the overall training. What is the course prerequisite? Should be good with the basic quantitative aptitude, right? The basic problems, logical reasoning, that basic, you should be good. Why is quantitative aptitude is related to this? Is that aptitude skill give you ability to understand the problem. Okay, and you should be able to do that logical analysis. Even today, what I suggest is, before you join the course, you should take a sample test anywhere. You go to internet and take a sample test. If you score anything less than 40%, right? Not even 30%, 40%. Okay. You should do the dedicated 1 month QA practice. Then only you should join the course. Because if you are not good with the basic logical reasoning, you forget, take VLSI, software, embedded, any course, you cannot cope up with that. Because your mind is not ready to capture the things at that level. Okay, minimum this much 40% is required. You just go to internet, one sample quantitative aptitude test. You take, let's say, 40 questions. Out of 40, if you score minimum 40%, then you join the course. Not only this course, any course. Otherwise, I'll tell you, you will be wasting your money. Without this, if you join also, you'll be wasting your money, because you can't understand. Let's say if I teach advanced things, your mind won't be ready to comprehend the things and connect the things. You may say, what 1 month magic will do? It happens when you sit full 1 month, do aptitude every day, some questions, you automatically, your mind starts figuring out the problems, figuring out how to come up with the variables, how to solve some variables based on the existing variables, how to write an equation. That kind of analysis is required. that kind of skill set is, then you join a training. Again, I'm repeating, if you are not good with minimum level of aptitude, when you join a course, you will be wasting your money. Okay, so please keep that in mind. Okay, so that is about prerequisites. Why join VLSIGuru? We charge reasonable amount. I mean, let's say we are charging some amount. Okay, uh, don't think that we are compromising on the quality of the training. We don't compromise on the quality of training. Okay, it is just that we reduce the expenses. I mean, our rental cost is not there. It's our own building. Okay. We do both offline and online batches at the same time. We don't run separate batches. We try to optimize the things to a point where we are able to manage in this cost. There are institutes who offer at 1 lakh also, 1.5 lakh also. There may, I mean, I haven't done any comparison. There could be institute which offer less than us also, probably. Okay. But we have our own unique things where first thing is we don't compromise on the quality just because we charge less. Okay. You will get a very good quality training. And I stay here only. I mean, I stay in the same building. So I track how the batches are happening, and we keep dedicated people to track your performance also. Even if you don't do well, let's say you're doing well, nobody shouts at you, nobody does anything. They try to encourage, they try to help you, but if you don't want to take the help, people will leave you. Let's say you don't want to attend mock interviews, you don't want to come to the sessions, you don't want to write evaluation test, they will call you, they will remind you few times, and after that they leave you. That I'll guarantee, because they won't have so much patience to go with every student like that. So you should have that proactiveness to take the support, and in this job market, that proactiveness is really required. It is not like 10 years back, 2013-14, the situation used to be a little different, where you complete a training, you had a very good chance of getting a job, because at that time VLSI much awareness was not there. Now there is a lot of awareness, there are a lot of people who join the courses, so hence there is of course increased competition. And then there is a problem of AI to some extent. Given all that, you have to be proactive. So even for you, make it an enjoyable experience where you find fun in learning. I mean, you enjoy becoming. I mean, you see as if by learning new things, you are becoming more expert with the subject. That is how I see. When I learn new things, new protocols, let's say, because even I have to keep upgrading myself as a trainer. Only then I'll be relevant for the industry. I find it enjoying. Let's say today I'm learning USB 4. Okay, till now we use USB super speed and those things only, right? USB 4 I learn. So for me it's a fun. Now I can get to see how USB 4 works. So that way I enjoy it actually. So you should also find enjoyment in what you learn. So our team will make sure that wherever you're stuck, they provide you this. Okay. So this is all about it. So skill set required and other things will teach everything. So you don't have to worry. So when you are coming here, I don't expect you to come with any basic concepts. I mean, if you are good with digital, that's very good. If you are good with Verilog, that's good. If you are good with C programming, that is good. But even if you are not good with Verilog, even if you are not good with C programming or not digital, you don't need to worry. We teach everything from the basics. Only thing is that simple guidelines, 8 hours in a day, make a notes, just prepare as per the trainer. I mean, today whatever topics I teach, you go home, sit and do those things. That basic thing principles you follow, after 6-7 months you will feel the confidence about your learning, and you can get a job. Okay. So yeah, I will yeah. Why VLSI job? VLSI job, one of the advantages is it's a well paid jobs, though initially when you start as a software employee only. Let's say software employee also starts somewhere around 3 to 5 lakhs. Even in VLSI you start with 3 to 5 lakhs. The actual salary comes after 3 years or 2 to 3 years, where you get better number than a software engineer. Okay, someone like, let's say, 5 years experience person, not only 5 years, I've seen people with 3 years experience getting almost 25 lakhs, 30 lakhs also. It is possible in VLSI. Okay, and the most important benefit of VLSI is you don't need to upgrade yourself every 3 years. In software, technologies keep changing. Completely a new technology comes. Actually, 6 years back, I used to hear the term big data, Hadoop, some terms. Now I don't hear. I hear some new things like 2 3 years back I was hearing data science. Now we hear AML. So the person to be relevant in software domain, they have to keep upgrading, learning new technologies. In VLSI, what happened? Whatever I learned around 2005, 2007 time frame, initial 3 years of my career, same knowledge I use now also. Same system Verilog I'm using, same UVM I'm using. So there is nothing like uh, .NET. Any new thing didn't happen. Same after 20 years also, my previous knowledge is still relevant today also. So that way your work-life balance will be better. There are a lot of companies who hire, and the more importantly, it's open for electrical, electronics engineers only, sometimes computer science engineers. So you don't have that full competition. But on a closing term, it's not like you do a training, you get a job. You have to learn, and you have to be, one thing you have to always keep telling yourself is, I have to prepare to a point where company will find my profile useful. I mean, company should be willing to hire me because I'm good with my skill set. That you should keep telling. Okay, so that is about it. So now if you have any questions, I'll address those questions. Any questions you have? Yeah.
Sir, you tell that for 2 weeks we have access for recording.
Yeah.
So is there any time limit?
Time limit will be there. See, generally what happens, let's say today I did digital design. My expectation is that you should complete digital design. 1 second. Our expectation will be that you should learn digital design within that one and a half month maximum. There's no point learning again after 6 months. So we keep the videos for limited access so that you will be serious about preparation. If I tell you that I'll keep the access for 6 months, then you will wait for 6 months. You're okay. You know that it will be accessible for 6 months.
Sir, I'm asking like for 2 weeks, how many times you can watch?
You can watch multiple times.
Time limit in total.
That is increased generally. That watch limit is generally increased. Sometimes people misutilize. To limit that, we have done that, but when you request, we increase the time limit.
Okay. Also, mock interview, you have to give after completion of topic only, or
you can request. See, you can request in the group. One group is created, right? There, once you are done with the topic, you can request saying that I want to attend a mock interview. Our team will schedule that. Let's take some of the questions. Those attending online, if you have any questions, please post in the chat box. Any other questions? Next, first let's take this question. Will this video be uploaded? Yes, it will be uploaded. Does weekend only batch work for more than 8 months? It will go for 8 months only. Or if there is something called as, there is one more thing called as self-paced learning, e-learning course. In e-learning course, you can finish the course in 4 months also, 1 year also. The e-learning course is a flexible mode of learning where you learn at your own pace, but every weekend there will be support sessions. Okay, that is mostly meant for working professionals. Okay, even here you can, like, based on your convenience, you can do it in 8 months, less than that or more than that. We won't have any restriction. But for a live training match, it goes for 8 months. What is the schedule? How it happens? initial 3 weeks, T means the starting date. Let's say T is the today's date. Okay. For first 3 weeks, we teach advanced digital electronics. Then one day will be an ASIC flow. Next, we'll start with Verilog for design and verification. Verilog language and Verilog projects will be there. Then that will go for 4 to 10 means 7 weeks actually. Okay. Then starting from 11th week till 18th week, that is how many weeks? 8 weeks actually. 11th and 18th included. Okay, that will cover system well. So this is where the differentiation comes. See, some of the other institutes I know, they do system log in 1 month. I mean, that's what I hear when I talk to the students from those places. For system log kind of language, 1 month is not sufficient. It's a very in-depth, and actually for whole things, system log is the foundation for whatever you do later. So hence we spend a lot of time, eight weeks only for teaching system log only. Once you are good with that, UVM won't take much time. Here we take only 5 weeks, 19 to 23. Linux will go for 1 week. Then industry standard projects will go for 7 weeks. 25 to 31 is 7 weeks. Then Python scripting for 2 weeks. SOC concept for 1 week. So this 33 weeks roughly comes to 8 months. But as I said, your placement support starts here only. That means around the 6th month of the training, you will start getting the placements. Yeah. Any other questions? We are closely connected with the industry. I mean, also, I was telling you the reason why we charge at less cost, right? We are connected with Synopsys, where we get it at a relatively lower cost. The tools. One of the main cost in running the program is the cost of the tools purchase. We get at a relatively lower cost. Okay, that we pass on to the student. We are one of the partners with Synopsys, where in fact we have in our VLSI there is one event called as SNUG, the Synopsys User Group. Our institute, even I was awarded there, and one more institute. Out of all the institute, we two were awarded because of our partnership with Synopsys. Okay. Yeah. Let me address the questions. What about the gap between education? Now, if you want to restart the VLSI field, see anything up to sometimes gap is actually advantage. Sometimes having gap is advantage. What is the advantage of gap is when you, let's say you are a 2021 pass out, for example. What some of the companies will do is they will hire you, they will show your education gap as an internal experience. Okay, they will say that you have been their employee for last 2-3 years, and they will project you as a experienced person to the client. That way they can easily place you in the project. So sometimes gap is good in that case. But if the gap is too much, let's say you are 2005 pass out, which is 19 years gap, that's a problem, because at 19 years finding opportunities is all little difficult. But then I have also seen people who are 2010 pass out and who got jobs also. Okay, it's not like 2005 means you will not get job. If you are very good, if you are skilled, you learn the things, companies will hire you. The age limit is generally, you know, right, up to 35 or something would be preferable. Once you cross 40, it's difficult. You may have to try as a experienced person at that level, maybe 4-5 years experienced person at that level. Okay, only then you can get a job. But see, there is nothing like you can't get a job. In all the possibilities, in all the cases, there is a possibility to get a job as long as you are good with the subject. I have seen a person who joined our course during 2020. Okay, 2020 or 2019, before COVID. He was 42 years and he was working as a faculty in Chennai, one of the colleges. We have many examples. I'm just talking about one of the examples. he took a long leave or maybe quit the job and he came. He did training, and exactly after 1 year he got the job. Exactly after 1 year. I mean, though he couldn't find immediately after 6 months, he was learning, he was putting effort, and then he was able to get a job. Okay. So gap after education, changing the career, age limit. Okay. Let's start with this question. I told you, right? In some cases, gap is actually good. Okay. It is good to extent where right now we don't have any person with 2021, 22 before passed out who don't have a job. I mean, who is good? Good. Simple definition of good is you complete 70-80% of the assignments. I place you under good category. Companies will readily hire them because for them it's easy to place them in many cases. Changing career and age limit. Again, as I said, right? So reasonable gap is good. Let's say you have gap of up to 4-5 years or even up to 7-8 years, it's manageable. Once you cross 10 years gap, it starts becoming more and more difficult because your age starts looking, right? I mean, when you are 23, 25, up to 30, people won't really find much differentiation. Once you cross 35, then you will have to work with a fresher who is 10-15 years lesser than smaller than you. There the gap will show up actually. Okay. If I'm in a regular batch student, by any chance, if I land in a job in initial stage, can I switch to weekend course? That whole flexibility will be there. I mean, I told you, right? After 6 months only, you may get a job. So we'll give you flexibility to switch to weekend course, or you can do the remaining course in e-learning mode. As an institute, we'll try to keep the things as much flexible as possible. Okay, because only if you are, I at the end of the day, students should be happy with the course, right? The flexibility provided by the institute and all that. Online code compiler. For self-paced learning, will the access for online code compiler? Yes, self-paced learning course is exactly same as live training course. Exactly means similar. Only difference is that live theory sessions are not happening. Okay. Over the weekends, all other facilities are same, exactly same. You will have the same placement support. You get the hard copy of the course material. You get the exactly the same course content. What is being taught in the live sessions, same content you also get to do, uh, and you'll have a dedicated mentor. The only difference being you are not attending live sessions. Why? What is the purpose of self-paced learning? Many times it is for people who are out of Bangalore, out of India. Let's say someone is in US. For them, almost 10 hours difference will be there. So this time for them it will be midnight, 12 o'clock. Okay. So for those people, we have the self-paced learning course, but all other benefits, all other features are same as the regular course. For 2 months of training session, laptop is required or subjects can be done on mobile. For initial 1 month, laptop is not required when we are doing digital design training. But after that, we suggest you to have your laptop. Even otherwise, you can use the systems in the institute lab room. We haven't kept many systems purposefully These days what happens is almost everyone has a laptop, right? See, when you come to Bangalore and do a training, minimum you have to spend 1 lakh, training plus accommodation and all that, right? So in those cases, people end up anyway purchasing the laptop. So I don't want to really maintain 200 systems or 100 systems. Pass on that cost to you. That cost will add to the training cost. Instead of X amount, it will become X plus 10,000. Okay. Rather, the flexibility of having laptop would be you can sit anywhere in the building. Just you have to connect to our institute network. We'll give you that also. Tell you, and you can use it anywhere. First thing. If at all someone don't have a system, they can of course use the institute systems that we have. Okay. Yeah, just to answer this question, initial 1 month you don't need a laptop, but after that you should have. What are the tools we are using? We use both Synopsys and Mentor graphics tools. So I will tell you how it works exactly. During the initial 2.5 months, you will use Model Sim tool. It is from Mentor graphics only. Later 2.5 months, you will use Questa Sim. That is from Mentor graphics. Last 3 months, you will use Synopsys tools. In that, most importantly, you will use a tool called as VCS and Verdi. Verdi is a very important tool. As a beginner, you won't really understand much of it, but when you go to the job, a lot of the industry people use Verdi tool, because as a verification engineer, you will have to do debugging. Means if something went wrong, where was that mistake happened? The Verdi is a powerful tool which helps you reach that point very quickly. Let's say if I have some design like this, different points are there. Some issue you figured here. You want to trace it. Okay, the issue could be here, issue could be here, issue could be here, issue could be here. Verdi is a very powerful tool which will take you in that direction very easily. Okay, other tools are not so user friendly, Verdi. So that's the reason final phase of training will involve. Why like this? Why not VCS throughout the course? Licenses are limited, so we have to use the licenses in a proper manner. So when you are using Questa Sim, previous batches are using this. When they pass out, you'll use this. Next batches will use this. So that way we optimize the licenses, and that's how the cost works out. Actually, okay. We can't buy 100 licenses. Okay. Yeah, this is about it. Next, how many people are placed during the recession period after completing the training? Actually, this is still not a recession. This is not a recession. Hiring is happening. Okay, a recession has a different meaning. Stock markets are going up. So technically, it's still not a recession. I mean, okay. Anyway, fun apart. Placements are happening. Companies are hiring. Maybe in a software, probably what I hear is the campus placement have been impacted. Is it true? Right. So, but in VLSI, frankly speaking, there have been placements. I mean, if I have to show our thing how it works, I'll show you. See, we maintain a group like this, DB job support group, where we keep posting the job updates. For example, there is a company which came today, which will tell initially they'll pay this. Once you are made after probation, they will increase. See, sometimes what happens, the salary will be around 4 to 5 lakhs, but initially during 3 months probation, they will pay you less, 15,000, 20,000 like that. Once you complete your probation and you're ready for the project, they will revise your salary. Okay. Next, say there is Bitsilica company which is hiring, which has a walk-in on 27 July. That is today only. Then Chipsol Technologies. When was it? It was on Wednesday. Okay. Then Bitsilica, same company. Then Iravan Technologies. It was on 19th of July. Then we have Prime Soft Technology, which was again on 19th of July. Okay. Then there are some companies like Synopsys. We didn't post here because Synopsys directly connected with me, I mean the manager. So he said, I need very good 7-8 people. So we don't post here. We have people like from every batch we know who are very good. So we pick those people and directly send them without even posting here. So there are such hiring, some which happen where we don't even post here. Okay. Like that, we keep posting here. So we give the link where you have to apply for that job. Once you apply, we conduct a basic level of mock interview for you to figure out are you up to the level, minimum level. If you are not good, we ask you to prepare and again come back after few weeks. My point is, when I share your resume with a company, there you should not spoil your chance and institute's chance also. So we do minimum level of screening before considering you for company. So our screening won't be very stringent. Simple, very simple. Like I will ask you some simple definitions, some simple coding examples, where we know that okay, you won't, when you go to interviews, at least you will speak, you'll have basic things to answer. Like this, we keep posting updates. So that is where I don't see a lot of slowdown, at least here, right? So this many opportunities for how many people we are talking about? Around 223. Right now we have 223. Out of 223, 10 people will be our admin only. So we are talking about 210 people. When so many companies come, even if a company hires 3-4 people, if you are good, you have a very good chance of getting a job. Okay. The difficult part of VLSI is starting, getting that career's first break. Just getting the job is the difficult part. Once you join the job, once you put effort and learn the things, after 3-4 years, you get a very good salary. See, you talk to any of your seniors, randomly pick any of your seniors, let him be 3 years experience. You ask what is your salary? Minimum it has to be 10 to 12 lakhs. You will not find any 3 years experienced person in VLSI domain who has a salary less than 10 lakhs. And that is a fact. You may even find a people with 25 lakhs, 30 lakhs if you go to companies like Qualcomm, Nvidia there. But any random company you take, minimum salary will be 10 lakhs. That you probably won't get today. But after 3 years, that normalization happens where you get that. So my suggestion would be, you should not be preparing from a job perspective. You should be preparing from a gaining expertise. You should become expert. Then automatically you will get opportunities. Okay. So it is for this person who said during recession, at least from our case, we are not seeing any recession. Companies are coming, companies are hiring. Salary part apart. See, not everyone is offering 5 lakhs, not everyone is offering 10 lakhs. As I said, to starting the career is important. Once you start the career, once you show your dedication in the job, once you put effort and learn the things and do the job properly, salary growth happens. For experience, when will be the placement support start? Your placement support starts after completion of UVM. Minimum expectation is that you should be good till UVM. Then your placement support starts. What number of companies comes to your institute? Okay, there are a lot of companies who do come. I mean, sometimes, as I said, right, let's say Siemens may have a requirement. They won't want 50 resumes. They will say, send very good some 5-6 resumes, because they won't have so much time to screen all 50 people. In those cases, we selectively hire the people. Let's say even today, last month or so, we may have shared some resumes to Siemens. Last week, we have shared some resumes to Synopsys. Okay, so that does happen. Okay, so we are connected with, I would say, close to 100 companies where you will get the opportunities. My only thing about placement is, I will not commit when you get the job, but till the time you get a job, we'll continue to support you. Means this group, what I showed you, may have people who have joined in 2023. It may have people who have joined in 2022 also. If I go down, you may find a people who have joined us in January 23, like different time, right? December 2022. So all these people are added into the one common group only. So there is no time limit where your placement support will stop. It will continue to be there. and you will also continue to get the support. Let's say even after 6 months you come back and say that I need some mock interview, I need some support. We will not deny that support, because we take it as a responsibility. We want to connect that long-term relation, where, because it's not just about making, I mean, you join, we collect the fee and done. It's more about helping you build your career. I think that answers most of the things. I signed up for FPGA system design training class. Are we covering all the topics that shows in the syllabus? Yeah, yeah, whatever is shown in the syllabus, these topics will be covered. Okay. Next, parallelly, can we attend interviews if we have some experience or particular domains? You can attend. I mean, we won't stop you. I mean, if you want to attend by your personal interest, you can attend. But when it comes to the training support from the institute, we need to be satisfied with your preparation level. Minimum level of preparation is required, then your placement support starts. The simple thing is, let's say you completed entire training, you can't answer some basic questions of Verilog. Can I consider the person for placement? In those cases only we deny. We won't say that we won't purposefully stop your placements. Only if we feel that your preparation is not up to the level, very poor, then we stop. Did product company do visit? Yes, product company do hire from the institute, but not as frequently as the way you see here. Any residents available connect with the institute. We are not connected with any paying guest PGs, but there are many PGs which are near the institute, and they mostly cater for the institute requirements. If you go to the PGs, more than 50% of the people will be from our institute only. They are very nearby, within half kilometer you will find many PGs from the institute. For online recording videos, access is how many days available? For online e-learning course, you can get access up to 8 months total. Generally what we do is, we don't give all the videos at the same time, because it becomes more confusing. We give it in a phased manner. First we'll give phase 1 topics, digital, Verilog, GWave. Once you are done with that, we'll give phase 2 topics. That way what happens, you have a specific timelines to prepare. If I give everything at once, it will be very confusing, right? Next, what if we placed with 4 to 5 lakhs, but 10 lakh per annum company will come, then can we apply? This flexibility right now is not there, because what happens, many times once you join, they will ask you to sign a bond. Okay, if it is services company, then if you break and come, it's all problem. Okay, I cannot commit on this part. Will you provide any certificate? Yes, it will be provided. The basic criteria for providing placement support is, mock interviews will be conducted. Your preparation should be decent. Again, if you carry a certificate of our institute where you are not good with basics also, then it spoils your chance also, our institute reputation also, right? So we make sure that we conduct a basic mock interview, where if we are satisfied, then we'll issue the certificate. Okay. Again, it is not purposefully, we won't trouble. We should have a confidence that you're good with the basics at least, then we'll provide all this. Any other questions? Okay, if you don't have any questions, we'll end the session here.
Hello.
Yeah,
So, like, will every company have the same policy of signing the bond?
depends. If it is a product company, they don't sign a bond. If it is a services company, why they sign a bond is, let's say you take an example of Wipro, for example. I don't know whether they take a bond or not. You join Wipro at some salary. Assume, let's say 4 lakhs per annum you join. It is not sure, it is not guaranteed that from day one you will be in a project. Initially for 4 5 months, they may keep you on bench. Then they will place you at project. After 5 months, let's say you leave the job, for them it's a loss because 4 5 months you are not doing anything and they were just paying you salary and they were taking care of your training and other things. So that is what sometimes people do, where after joining after 5 6 months they quit the job and join some other company. Okay. uh, to protect
Mm.
that, they take a 3 years bond. Yeah, just to keep it straight to your question, yes, in many services companies do take a bond. Product companies don't take a bond because they are already paying high, so chance that you will leave is very less.
Okay. And usually this bond is of 3 years, like usually.
Yeah, it will be 3 years, but they won't keep you on the same salary. They will give you a revisions, proper revisions also. Only thing is they don't want you to switch. I mean, let's say
Mm.
you start at 4 lakh, your 4 lakh for 3 year salary won't be 4 lakhs only. They may make it 4 to 6, 6 to 8 lakhs also. All that they will do. It's just that they want you to be stable. They should have visibility that you are there with them for 3 years. Let's say I have a trainer joining. After 1 month he leaves. It's a problem. Whole my planning goes wrong. If I know that this trainer will be there for me for 3 years, I plan my batches accordingly. I plan my hiring accordingly. So that is the reason they take bond.
Okay.
For
Yeah.
e-learning, should we pay again if you don't finish the course in 8 months? Generally, this 8 months, as I said, can be spread over 12 months also. You can even spread your course over 12 months. But beyond one point, yes, we do ask you to pay some nominal fee per week basis. Okay. Uh, but as I said, this 8 months can be spread to 12 months also. It is possible. Any other questions?
Sir, I was a test engineer. Now should I go for the fresher or for the experience? And today we did the front-end.
Yeah.
Should we attend tomorrow back-end?
No, if you are comfortable with programming, you just go ahead with the front-end domain training. You try for 2 months. I mean, you do this course for 2 months. After 2 months, if you feel you're finding it difficult with programming, then you switch to backend domain. Okay. So
should I go with the fresher thing or
fresher, if you are you comfortable with Verilog language? Again, what level of comfort you have to ask. For if I give you something like FIFO, will you be able to develop a design and will you be able to develop the test bench? Fresher. Let's say even in Verilog, I'll tell you, even in Verilog, let's say you're comfortable with language. You're comfortable with language, all those things, then you can skip that part. You can join only the projects. You can start from the Verilog projects. Accordingly, the fee will be reduced for you. The fee part also will be reduced because if you are not doing digital and Verilog language, that part of the fee will be reduced. So there is no compulsion that you have to only start at digital. If you are all, if any of you are very good with digital, let's say you have done a gate preparation and you are very good with digital, so you can skip digital and directly start with Verilog. So there won't be any such restriction because even if you want to start Verilog project, there will be a project course batch running. You will join into that batch. Any other questions? Uh, course will be commencing. The course will be starting on Monday, that is 29th onwards, 29th July. In case you want to enroll, you can talk to our enrollment team. You can pay 5,000 and confirm your enrollment. So this link will be there where all the details will be there. So any other questions you have? Okay, fine. We will.
Will you
Yeah.
be the teacher or another trainer will be there?
I won't handle all the topics. Okay, there will be other trainers who will be handling the topic based on their expertise. Let's say digital design is there. I'm comfortable with digital design. I can teach. Problem is I'll have other batches also to handle. So we have other expert trainer for digital design who will handle digital design. Let's say when it comes to very large, we have expert trainer. So depending upon the trainer expertise level, those trainers will handle that topics.
Okay. Uh,
Yeah.
may I have a short call with you over mobile phone?
Okay, sure. I'll share my number to that you can call.
Okay, sure. Thank
I sent in the chat. You can make a note. Okay.
you.
Let us end the session.